Hi there guys, in this video we're going to have a look at how we solve an equation when we've got indices. And it's quite simple really, you've just got to remember one thing, take logs. So I'm just going to write that down there, so I'm going to take logs, and with an equation what you do to one side you always do to the other side. So when we take logs, it's nothing more than just writing log in front of everything you've got on both sides. Now, if you're watching this video, you've probably done some work with logs already, and you'll know that there should be a base number here. Now, if we just write log, in theory, what we can do is take the base value to be anything. As long as it's the same to both sides, it's not going to matter. But generally, when we write log, we're using base 10 because our calculators, there's a button called just a log button, and that will automatically take it to a base 10. Okay. Now hopefully you've looked at the laws before and this isn't going to come as a surprise, but if you've got a power here you can apply the power law, which means you multiply. So I can write it as x log 3, and let's just rewrite the right hand side. And log 3, when you type it in, that's just a number, so it's a constant term, like 2 for example. So if we had 2x, you'd divide by 2, but we haven't got 2, we've got log 3x. So we're going to divide by log 3 to both sides, and there we have the answer. So we're going to quickly type this in. Now, if you're using the ClassWiz, the latest model from Casio, logs are quite frustrating. You've got this button here, but when you press that, you have to put the base value in. Normally there's just a log button, but on here for some reason it's shift and then the negative, so that will automatically do it to base 10. So let's pop this in. So log 7 over log 3, close the bracket off, and we're going to write that as 1.77 to 2 decimal places, or 3 significant figures. Now there is another way you could have done this. If you rewrite this using logs, so I'm not going to go over this too much, but if we take the log of 7, the base value of 3, that will also give us x. But looking forward, this is the method to go for. We're going to start looking at natural logs very soon, and there isn't this shortcut method. So get in the habit of treating an equation like you normally do. What you do to one side, you do to the other. And that's going to become more important here. Okay, so we're asked to solve this, so we're going to just take the log of both sides. And again, excuse me, we've got a power, so we can apply the power law. So we've got x plus 1. I'm going to just put that in brackets for now. Log of 2 equals log of 9. Now, remember, this is just a constant value. It's really no different than writing that. And if you saw that, you'd probably think, oh, let's expand this. But we want to get x on its own. So there's no need to do that. We can just leave this term here on its own by dividing by log 2. So we're going to get x plus 1 equals log 9 over log 2. And to get x on its own, we're going to do log 9 over log 2, take away 1. So I'll leave you now to type that into your calculator and get your answer for x. Let's have a look at another one. Okay, this one's much harder because we've got x's on both sides. So if you think back to linear equations, when you had x's on both sides, you got them all on one side, or the x terms on one side, or the number terms on the other. This is what we're going to do. We're probably, though, going to have some rearranging. So if you had something like this, let's say we've got this rearranging problem, and I said let's make x the subject. When it's in 2 terms, use to factorize. So that's all we're going to use this in this question, just all the basics of rearranging and getting all the x's on one side. Okay, so we've got an equation with indices. Let's take logs. So log of 3 x plus 4 equals log 6 to the x. Remember, these are any base I want, okay, at this point. Use the power law, so let's bring that down. Okay, so I've got x plus 4, log 3, and I can bring this x down as well, log 6. Okay. So now, we're thinking, like I said in the previous video, we've got this value times this. So I am going to expand. When I've got x on both sides, I am going to expand, get the x term out, and then I can get all those on one side and all the non-x terms on the other side. So imagine this was like a 2. You'd have 2 times x and 2 times 4. But it's log 3 times x, so we have x log 3 plus 4 log 3. And that's equal to x log 6. So you can see now we've got this x term here and an x term here. They need to be on the other one side, and this needs to be on the other side. So let's move this one, because that's the less effort, if you like. So I can write 4 log 3 equals x log of 6 minus x log of 3. Now, we're here. We've got 2 terms with an x in, so we factorised. We've got 2 terms with an x in, so we'll factorise. Log 6, take away log 3, equals 4 log 3. And now to get x on its own, we can divide both sides by this bracket. So we have 4 log 3 all over log 6, take away log 3. And again, to save time, I'll let you type that in to get your answer. And of course, when you get your answer, you can always pop it back in here, store it as A or use your answer button. Probably store it as A, because then you can work out both. Put it in here and put it in there. Just make sure that this side equals this side. Okay, best of luck.